So this is lesson 7, our first new lesson for the quadratic functions unit. So lesson 7 is determining equations of parabolas. Before we start the lesson, I do want to do a quick review of the 3 different forms of equations for parabolas. So we have standard form, we have factored form, and we have vertex form. So with standard form, essentially the equation for a parabola would look like this. Y is equal to ax squared plus bx plus c. With factored form, it would look like y is equal to a, x minus s, x minus t. And with vertex form, it will look like y is equal to a, x minus h squared plus k. So we dealt a lot with the vertex form when we were looking at graphing parabolas. We started to talk about factored form. Remember, the significance of the vertex form is we can read the vertex right off of this. The significance of the factored form is that we can read the x-intercepts right off of the factored form. We will touch base on standard form in the subsequent lessons. So what we're going to focus on today is how we can essentially come up with the equations of a parabola by using clues. So up until this point, I've given you a graph of a parabola and you've been able to determine its equation. Now we are going to figure out the equation from clues that are given in the question. So families of quadratic equations. So before we're able to create those equations, we need to define some terminology. So families of quadratic equations, a family of a quadratic equation is a group of quadratic equations which all share a common characteristic. There are 2 different characteristics that all of the members in a family of quadratic equations can share. They can either share their vertex or their x-intercepts. So here I have the equation in vertex form, and I'm going to give you an example of a family of quadratic equations so that you understand what they are. So one member of this family is 3x minus 1 squared plus 5. And another member of this quadratic equation, of this quadratic equation family is g of x, which is equal to negative 2x minus 1 squared plus 5. Now we said that if the vertex of 2 functions, quadratic functions, are the same, then they belong to the same family of quadratic equations. So remember, this is in vertex form, so it's easy to read the vertex right off of it. So the vertex, we take our h value, which is negative 1, but we take the opposite, so it would be 1, and we take our k value, which is 5. If we take a look at our second function here, again, the vertex, we take the opposite of negative 1, which is 1, and we take the k value, which is 5. So both of these functions share the same vertex. So we say that they're members of the same family. In fact, you can call it family with vertex 1, 5. So that's their family name. They're all members of this family that have the same vertex. What you should notice is really the only thing that differs between members of the same family are the a values which appear in the function. So now I want you to take 5 seconds, think about 2 other examples of other members who would be a part of this particular family, the family with the vertex 1, 5. In the space provided here, write down your answers. So I'm going to give you about 10 seconds and then we'll take it up. Okay, so there's a plethora of possibilities here. You can write hx is equal to 75, x minus 1 squared plus 5. you can write kx is equal to just x minus 1 squared plus 5 because there's a secret 1 there. So again, because all 4 of these functions share the same vertex, they're all a part of the same family, and we call them different members of that family. So that's one way of getting a family of quadratic equations, making sure that they all share the same vertex. Another way is by making sure that they all share the same x-intercepts. Again, when we talk about x-intercepts, it's more appropriate to move to factored form because we can read the x-intercepts right off the equation. So an example, so we have f of x is equal to 3x minus 5 and x plus 2. Another member of the same family could be g of x is equal to negative 7x minus 5, x plus 2. So if we take a look at the new equations that I've written, let's think about the x-intercepts here. So the x-intercepts, so remember, this is in factored form, and we take the opposite of the number in the factors. So this is x minus 5. The opposite of minus 5 is 5. So one of the x-intercepts occurs at 5, 0. And the other one, here it's plus 2, so we take the opposite, occurs at negative 2, 0. Similarly, if I take a look here and at the x-intercepts, again, I have negative 5. I take the opposite, so the x-intercept will be positive 5. And here I have positive 2. I take the opposite. It'll be negative 2, 0. So now again, we have members of the same family because they both have the same x-intercepts. The only thing that varies, once again, is this particular a value. So we can say that we can give it a family name. This is the family with x-intercepts 5, 0, and negative 2, 0. So as you can imagine, there are several different types of families we can form because there could be a whole infinite possibilities of vertices and infinite possibilities of x-intercept combinations. But what we need to recognize is being able to identify the members of that particular family. So once again, I'm going to give you about 10 seconds. Think of 2 other members of this particular family. So the family with x-intercepts 5, 0 and negative 2, 0. Okay, so let's write down some examples. Another member of this family could be 8x minus 5, x plus 2. Another member of this family could be pi, 3.14, and the rest of it, x minus 5, x plus 2. So as long as the x-intercepts stay the same and it's only the a value that's changing, again, we have members of the same family. So the only factor that varies between members of the same family is the a value. So remember, if you take a look at the 3 forms here, you'll notice that the a appears at the beginning of each of the forms of the quadratic equation, and those will always be the same. The a value here is the same as the a value here, which is the same as the a value there. To determine the specific a value, so in a question, I might give you clues such as what are the vertex of an equation, or what are the x-intercepts of an equation. That will tell you a lot of information. What it won't tell you is the specific a value. To find the specific a value, a point on the function is required. And we'll go over what that means through our next couple of examples. So family problems, okay, I didn't mean to name it that, but families of quadratic equations problems. For these problems, you'll be determining the equation of a parabola using clues. So this should say parabolas. using clues. If you're given the vertex and a point, so remember, they'll give you some sort of clue, but they always have to give you a point to find the specific a value. You obviously want to use vertex form because that's where it's easy to incorporate the vertex. And if you're given the x-intercepts and a point, you want to use factored form. So let's take a look at our first example. It says the two x-intercepts of a parabola are -3, 0, and 2, 0. A point on the parabola is 4, 6. Find the equation of the parabola. First thing you want to do is essentially look at these rules. Are you going to use vertex form or factored form to determine your equation? Because we were given two x-intercepts and a point, we are going to go with factored form. So what I suggest is you start by writing the general formula for factored form, which is y is equal to a x minus s x minus t. Once you have this form, you can start putting in the clues that they've given you. They've told us that the two x-intercepts are -3, 0, and 2, 0. We know that the x-intercepts are essentially read using the factors. So what we're going to do is we're going to put in the proper x-intercept values into our equation. So we don't know what our a value is. We don't know what our x value is yet. We have this minus. We know that our x-intercepts are the values that go into our factors. So we're going to take the -3, and I'm going to put that in as my s. And here, again, the 2 is an x-intercept. It should be a part of my factor. I'm going to put it in as my t. Something to keep in mind, the order of these don't matter. So if you put 2 here and -3 here, it wouldn't matter. But what you do need to remember is because the negative is a part of this equation, you always keep the negative, and whatever values they give you for your x-intercepts, you're going to put in as your s and t value. So ultimately, if I was to simplify this, I have x minus -3, which is just x plus 3, and x minus 2, which is just x minus 2. At this point, sorry, you should copy down the y as well. At this point, check your work. You know that the factors in a quadratic equation will be the opposite of the x-intercept. So here I have +3, which makes sense because my x-intercept is at -3. Here I have -2, which makes sense because my x-intercept is at +2. So we were able to determine the s and the t value using the x-intercepts. That's great. But we still haven't figured out this a value. So remember what I mentioned up here, to determine a specific a value, you need a point on the function. The point that they gave us in this question is 4, 6. So we have 4, 6 as our point. We know that this represents the x variable, and we know that this represents the y variable. So now we have values that we can put in as x and y into this equation. So I'm going to do it up here so that I have more space. So I have a y value now, which is 6, is equal to a. I have an x value, so 4 plus 3, and 4 minus 2. So all I did was I replaced the x's here with 4 because that's what my point told me, and I replaced my y here with 6 because again, that's what my point told me. Now I can simplify further. I have 6 is equal to a, 4 plus 3 is 7, and 4 minus 2 is 2. So 6, 7 times 2 is 14a. Now the whole point of this was to isolate for that a. So to isolate for the a, I need to divide both sides by 14. So a is equal to 6 over 14. But I wouldn't stop there. We can simplify this fraction by dividing both the numerator and the denominator by 2. So a is equal to 3 over 7. Once you have all of this information, you need to go back into your equation and finish it. So we stopped here with the equation y is equal to a x plus 3 and x minus 2. Now we have a specific a value that we can fill in. So y is equal to 3 over 7, x plus 3, x minus 2. And with that, we've determined the equation of our parabola using clues. So something to keep in mind, all of our equations will have x's and y's left as is. You just need to fill in all the other numbers. So in this case, the a, the s, and the t. In this step, we did have to replace the x with 4 and the y with 6, but the sole purpose of that was to find the a value, which we could go back and put into this equation. So that's how we solve a family of equation problem, because essentially this is a specific family. It's the family of parabolas with x-intercepts -3 and 2. What we did from there is we found a specific member of that family by finding the a value and plugging it in. Hopefully that's clear. If not, let's go through the second example, which is very similar. So the second example here, it says the zeros of the parabola are 1, 0 and 6, 0. A point on the parabola is 5, 3. Find the equation of the parabola. So just some reminder of terminology. Whenever you see the word zeros, that also means x-intercepts. So they've given you the x-intercepts. They've also given you a point. Again, follow these rules. If you're given the x-intercept and a point, you're going to start with factored form. So again, let's start by writing out the skeleton equation for factored form. Just like before, we were given 1, 0 and 6, 0 as our x-intercepts. We know that those numbers essentially make up our s and t value. So let's plug them in. So here we have y, which we don't know yet, a, we don't know yet, x, don't forget to copy down the minus and then put the value in, so x minus 1. And here we have x minus, again, copy the negative and then put the value of t in, 6, which is 6. So this essentially simplifies to give us x minus 1 and x minus 6. Again, stop and make sure you're correct. This has a -1, the opposite would be 1, so that makes sense that that's an x-intercept. This is -6, the opposite would be 6. Again, makes sense that that would be an x-intercept. So we found again our family. This is the family of equations with x-intercepts at 1, 0 and 6, 0. Now we want to find our specific member, so we need a point on the parabola. The point that they gave us was 5, 3. Again, the 5 represents our x value, and the 3 represents our y value. So we can go and plug in this information into our equation. So the y is 3 is equal to a. I now know my x, which is 5 minus 1, and here 5 minus 6. Again, I can simplify. So here, the 5 minus 1 gives me a 4, and the 5 minus 6 gives me a -1. So this side doesn't change. 4 times -1 is -4. So on this side, I have -4a. And now to isolate for the a, I need to divide both sides by -4. -4, -4. So what I'm left with is a is equal to -3 over 4. Once you have your specific a value, the point is to go back and plug it in to this general skeleton equation. So y is equal to a, x minus 1, x minus 6. And we now know that the y value is -3 over 4, x minus 1, x minus 6. Again, to recap, you want to keep the x's and y's in your final equation. You want to fill up all the other numbers, in this case, the a, the s, and the t. So both of these questions used the factored form. Just to recap, when they give you the x-intercepts, those are the values that go into your s and the t. Don't forget to copy down the negative and then put in your x values for the x-intercepts, or you will get the wrong answer. And then once you have your family of equations, you want to essentially put in your x and y variables from the point to solve for the a value. We have two more examples. So the next example is create the equation of a parabola in standard form. So in this case, they told us that we need to eventually convert our answer into standard form. So look for clues like that as well, which contains the vertex -3, 4 and contains the point 0, 10. So there's multiple layers to this. If we go back to these instructions, it says, if you're given a vertex and a point, use vertex form. So that's what we are going to start with. So start by writing the general equation for the vertex form. So y is equal to ax minus h squared plus k. They told us that the vertex is -3, 4. So we know that this is our h value, and this is our k value. So what we're going to do is we're going to put them into our equation. So we have a, so y doesn't change, a doesn't change, x, it's still a minus, so I'm going to write the minus first and then put my h value as -3. The k value is +4, so I'm going to put +4. If I simplify this, I have x minus -3, which is the same thing as x plus 3 squared plus 4. So again, at this point, check your work. If I gave you an equation like this, I know to read the vertex, I would take the opposite of this value, which is, so this is 3, so I would take the opposite, which is -3, and I would take this value, which is 4. So this suggests that I'm on the right track because it gives me that same vertex. So again, this is a family of equations. All of these equations, regardless of the a value, will belong to the same family, but we want to find that specific member. So just like in the previous questions, in order to do that, we need a particular point. The point we're given in this case is 0, 10. 0 is our x value, 10 is our y value. Now we can go and plug these in. So y is equal to, sorry, let's plug it in. So the y value they gave us was 10. 10 is equal to a. The x value they gave us was 0. So 0 plus 3 squared plus 4. So simplifying this, 0 plus 3 is 3, and 3 squared is 9. So I have 9 times a plus 4 is equal to 10. I'm trying to isolate for the a because I want to find the specific member of this family. So the first thing I'm going to do is move the 4 over. When I move it over, it becomes -4. So I have 6 is equal to 9a. And then to isolate for the a, I'm going to divide both sides by 9. So I have a is equal to 6 over 9. And again, you want to simplify as much as possible, so I can divide the numerator and denominator by 3 to give me 2 over 3. So now that I have my specific a value, I can plug it back into the skeleton that I had here, so the family of equations. So y is equal to a, x plus 3 squared plus 4 is the same thing as y is equal to 2 over 3. X plus 3 squared plus 4. But we are not done here because I've now created my equation in vertex form. So again, you notice that the y and x are intact. We just replace the other values, in this case, the a, the h, and the k. This is incomplete because the question said create the equation of a parabola in standard form. So we now have our equation in vertex form. We want to get to standard form. And to get to standard form, we need to multiply out and essentially simplify this expression. I don't have enough space here, so I'm going to flip the page. And so we'll do it on, so just give me 2 seconds. Okay, so I just flipped the page, wrote the exact same equation out. If we are trying to find this equation in standard form now, we just have to multiply everything out. So just a reminder, when you have something like x plus 3 squared, I've told you to rewrite it as x plus 3 times x plus 3 plus 4. When you're multiplying out, it's better to leave the number for now and to multiply these two terms out, or these two factor brackets out first. So you have 2 over 3. And let's multiply this out. You have a binomial being multiplied by a binomial, so you want to use the distributive property. So x times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And 3 times 3 is plus 9. We didn't do anything with the plus 4, so keep it outside for now. We want to keep going, so let's simplify inside the bracket. Let's collect like terms. There's nothing I can really collect with x squared, but I know 3x plus 3x will give me 6x plus 9. Again, there was nothing to do with the 9, and no other terms to collect with the 9 inside the bracket. So just keep in mind we're working inside the bracket. You can't add the 4 yet because that's outside the bracket. Now we have multiplication here and addition. Based on bed mass, we need to do the multiplication first. So here we have a term being multiplied by multiple terms. We need to use distributive property once again. So 2/3 times x squared is 2/3 x squared. 2/3 times 6x. So if you need to do this on the side, please do so. So 2/3 times 6x. I can rewrite this as a fraction by putting a 1. I can start simplifying this because 3 and 6, I can divide both of them by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. And now I have at the top 2 times 2x, which is 4x. And at the bottom, 1 times 1, which is 1. And 4x divided by 1 is just 4x. So 2/3 times 6 x is the same thing as plus 4x. And then I have 2/3 times 9. Again, do it on the side if you need to. So 2/3 times 9. Again, I'm going to create a fraction by putting a 1 underneath the 9. And again, I can cross things out. So the 3 and the 9, we can divide them both by 3. So at the top, we have 2 times 3, which is 6. And at the bottom, 1 times 1, 6 divided by 1 is just 6. So we've gotten rid of the brackets by using the distributive property. And now we have plus 4. And then we continue to simplify. So we have 2/3 x squared plus 4x. I can collect these like terms to give me plus 10. So essentially what we did was we had to start with vertex form because those were the clues that were given to us, and then we multiplied out to get us to standard form. So I'm just going to flip the page and I'm just going to write that down in the same space so that we have our final answer. So y is equal to 2/3 x squared plus 4x plus 10. Again, we only converted to standard form because that was required of us from the question. We'll do one more example and that will be it. So if we look at this, again, it says create the equation of a parabola in standard form, which contains vertex -2, -1, and contains the point 1, 9. So we'll write out the skeleton equation for vertex form. Y is equal to ax minus h squared plus k. They gave us the vertex, and again, this is our h value, that is our k value, so we can plug that in. So y is equal to a. Don't forget to copy the negative that's already there and then add your h value. So because there's a negative in our h value, we're going to put that in as a separate negative, and we put in our k value as well. Then we simplify. here we have x minus minus 2, which becomes plus 2. So x plus 2 squared minus 1. Again, check your work. If I was to read the vertex off of this, I have a 2 here, so I take the opposite, negative 2, and I have negative 1. So I know I'm on the right track. Again, to find, so this is the family of equations. I want to find a specific member, so I need the point. So I have 0.19. The 1 is my x, the 9 is my y. So now I can plug these in. So y is 9, so 9 is equal to a. X is 1, 1 plus 2 squared minus 1. I can simplify this. 1 plus 2 is 3. 3 squared is 9 minus 1. So I have 9 is equal to 9a minus 1. To isolate for the a, I'm going to bring the negative 1 over first. So 9 plus 1 is equal to 9a. So 10 is equal to 9a. And to isolate for the a, I'm going to divide both sides by 9. And so I have a is equal to 10 over 9. Now that I have my a value, I can put it back into my equation, so my family of equations. So y is equal to ax plus 2 squared minus 1. I have my a value now, which is 10 over 9, and so I plug that in. Again, this is vertex form, which is fine, but the equation or the question said, write it in standard form. So we're going to have to multiply this out now. So we have y is equal to 10 over 9, x plus 2 squared minus 1. Just give me 1 second. I'm trying to figure something. Okay. And so what we're going to do is, again, whenever you have something like this squared, you want to rewrite it as x plus 2 times x plus 2 minus 1. You want to use FOIL to multiply this out. So x times x is x squared. X times 2 is plus 2x. 2 times x is plus 2x. And 2 times 2 is plus 4 minus 1. We continue to simplify. So y is equal to 10 over 9 x squared plus 4x plus 4 minus 1. So I just collected the like terms here. Now we just have to multiply out. So again, here we have 10 over 9 times x squared, 10 over 9 x squared, 10 over 9 times 4x. Again, if you need to do it on the side, do so. I'm going to make this into a fraction, but what I see is there's not really anything I can reduce. So the top is just 10 times 4x, which is 40x, and the bottom is 9 times 1, which is 9. So here I have 40x over 9. The next thing I have is 10 over 9 times 4. So again, 10 over 9 times 4. Again, there's nothing to reduce. This is just 40 over 9. So plus 40 over 9 minus 1 over 9. Sorry, minus 1. Minus 1. So what you notice is we can continue to simplify because these two terms can be collected. So we have 40 over 9 minus 1. Because this is a fraction and we're subtracting, we want to make them both fractions. So I'm going to rewrite this as 1 over 1. When I'm subtracting fractions, I need to make sure that I have a common denominator. So here I have 9, here I have 1. The common denominator is 9. So I'm going to multiply both the numerator and denominator here by 9. So 40 over 9 minus 1 times 9 is 9 over 9 is equal to 31 over 9. I keep the denominator and just subtract the numerators. So essentially, I'm left with 10 over 9 x squared plus 40 over 9x plus 31 over 9. And again, that's my final answer in standard form. So this is essentially the lesson with the families of equations. On your sheet, you should also have the homework. So the homework is page 204, number 8 and 12, as well as page 141, number 12. If you are in Mr. Thavis Warren's class, you need to finish this homework, take a picture of it, and submit it through the Google Classroom. Thank you.